To prove that this is a multiple of 6, we're going to expand both pairs of brackets. So we have 3n plus 1 multiplied by itself, and then take away 3n minus 1 multiplied by itself. So now we have 3n times 3n, which is 9n squared, 3n times 1, which is 3n, another 3n times 1, and 1 times 1, which is 1, minus, and we'll put this in square brackets. So now we have 9n squared minus 3n, minus another 3n, and a negative 1 times a negative 1 is positive 1. So we'll tidy up both terms. We can collect these two together. So we have 9n squared plus 6n plus 1. This is negative 6n, and we'll multiply out the negative. So we have negative 9n squared, positive 6n, because these negative 6n's multiplied by a negative become a positive, and then minus 1. And we can see this positive 1 will cancel with a negative 1, and these 9n squares will cancel with these negative 9n squares. So what we're left with is the 6n plus 6n, which is 12n. And to prove that this is a multiple of 6, we can pull out the 6, and we're left with 6 lots of 2n. So now we need to state that an integer multiplied by 6 is by definition a multiple of 6. So we need a final written statement to back up our algebra. To simplify this fraction, we need to factorize the numerator and the denominator each in the two pairs of brackets. So if we have x squared minus 8x plus 15, this is the same as x minus 5 and x minus 3. And the denominator is simplified to make 2x plus 3 lots of x minus 5. Now we can see the x minus 5 will cancel with this x minus 5, so we're left with x minus 3 over 2x plus 3 as our simplified fraction. So here we have a function of x, and the turning point is at 2, 5. So when x equals 2, y equals 5. Now we're going to transform this function through f of x minus 3. And this means we move the function 3 units to the right. So it's a horizontal translation, 3 units to the right. So this point becomes 5, 5. To find the equation of a line which is perpendicular to this and passes through the point 9, 2, I need to arrange this equation in the form y is equal to mx plus c, where m is the gradient and c is the intercept. So I need to make y the subject. So I'm going to begin by taking away the 3x from both sides. So y is equal to minus 3x plus 7. And now I can sketch this graph. So you can see we have an intercept of 7 and a negative gradient. We're being told that the line is perpendicular and passes through the point 9, 2, which I can sketch at about here. And because it's perpendicular, it will cross the blue line at 90 degrees. So this would be a right angle. Okay, so now we have a perpendicular line. We know the gradient will be the negative reciprocal of negative 3. And this gradient will have an m value of positive 1/3. So we have y is equal to 1/3 of x plus the intercept. And we can find the intercept using this x and y value here. We'll substitute in the y equals 2. And this is 1/3 of x, which is 9, plus c. 1/3 of 9 is 3, so 2 equals 3 plus c, so c will equal -1. So the equation of a line perpendicular is y is equal to 1/3 of x minus 1. So we can have a probability of two different colours will equal 1 minus the probability of choosing the same colour, because it is certain it will either be the same colours or different colours. So in this case, we've got 1 minus the probability of red and red, or the probability of blue and blue, or the probability of white and white. This will be 1 minus for red and red. Well, the first time we take a red, we've got 9/20. And then when we take a red, we've got 8 red lefts and 19 in total. For blue, the first blue probability will be 7/20. Then we take one blue away, so we've got 6 now over 19. And then for white, we've got 4/20 to begin with, and we take one away, so we have 3/19. And we'll close this bracket. So now we have a probability, and we can work all of this out, and we get 1 minus 63/190. And this is 127/190 for a probability of choosing two different colours. For these two similar shapes, we're told that the surface area of A is 36 centimeters squared, and the surface area of B is 100 centimeters squared. So from these two surface areas, we can find the area scale factor, which will be 100 divided by 36 centimeters squared. These units will cancel, so we're left with 100/36, which is 25/9. So now we have the area scale factor, we can find the length scale factor as the square root of this. So we have the square root of 25/9, which is 5/3. And we've been asked to work out the mass of A, so this means we need a volume scale factor. And this is the length scale factor cubed. So we'll cube 5/3. And this will give us 125/9. So now the mass of A will be the 400 grams, the mass of B, divided by 125/9. So the mass of B divided by the volume scale factor. And this is 86.4 grams. To work out the area of this blue shaded region, we need to think of this as a sector, take away the triangle, and then we'll get the area which is blue. So I'm going to show these as two separate diagrams. The area of a sector then is theta over 360 pi r squared. We know that theta is 60, so 60/360 is 1/6 of pi times the radius 8 squared. So this will be 64 pi/6. The area of a triangle, we can use half AB sine C. So 1/2 of each length, the 8 and the 8, which is 64, times the sine of angle C, which is 60, and this will give us 16√3. So the blue area would be the area of a sector, 64 pi/6, minus the triangle, 16√3, and this will give us 5.8 to 3 significant figures. To work out the maximum of the upper bound of the pressure, we need the maximum force or the upper bound of the force divided by the minimum area, which is the lower bound of the area. So the maximum force, well, we're told is 325 doing here is 5, so this becomes 327.5 newtons, which is the upper bound. And the minimum area, to work this out, we need to work out the two minimum possible lengths here and here. So this would be 5.15 meters with a length and 2.05 meters with a width. So the minimum area will be 5.15 meters multiplied by 2.05 meters, which gives us 10.5575 meters squared. So the upper bound of the pressure will be the maximum force, 327.5 newtons, over the minimum area, 10.5575 meters squared, which is approximately 31.02 newtons per meters squared.